which is f of x is equal to mod of x minus 3 plus mod of x minus 4, then show that f of x is not differentiable at x is equal to 3 and x is equal to 4. I'm going to do the sums for differentiability. So let's look at x is equal to 3. Just call this point as x is equal to 3. Differentiability means you have to come from top to bottom like this and like this. Okay. So for the right limit, the formula is, supposing there is a point here which is a, you're going to come like this and come like this. Right limit is f of a plus h minus f of a by h. Limit h tends to 0 for the left limit, and for the right limit, and for the left it will be limit of f of a minus f of a minus h by h. These are the formulas for the left and the right. Your textbook will say f of a minus h minus f of a by minus h. It doesn't matter how you say. So I'm going to put it in the formula. What is the formula for the right limit? F of a plus h minus f of a by h is the formula for right hand derivative, not right hand limit, RHD, which is f of 3 plus h minus f of 3 by h is what is limit of f dash of x when x is tending to 3 from the right. So in this, again similarly, we're going to write a left hand derivative, which is limit of f dash of x extending to 3 from the right. In that case, its formula is f of a minus f of a minus h by h. As I told you in the book, they would give you this, swap it, and they'll put a minus sign below. You can also write that, but I would like it like this. So it's f of 3 minus f of 3 minus h by h. Okay, so this is for the left and this for the right. So now go back. There's no need for redefining. Just f of 3 means what? In this, f of 3 means mod of 3 minus 3 plus mod of 3 minus 4, which will be 0. This minus 1 will become plus 1 because with the mod. So answer for this is 1 minus f of 3 minus h. 3 minus h mod of 3 minus h minus 3 plus mod of 3 minus h minus 4. I'm substituting in the place of x 3 minus h. 3 and 3 get cancelled. H will become just minus h will become plus h. Eventually it will become 0. Plus this will become mod of minus 1 minus h. Okay, minus 1 minus h. And so here if h becomes 0. Okay, look at this. Okay, what is this that you're getting here? Is h and this mod function, so it is plus 1 plus h. So it is 2h plus 1, is it? So 2h plus 1 by h. Okay, I'm trying to do it again. 3 minus h. So then wherever x is, I'm putting 3 minus h. So 3 minus h minus 3 plus 3 minus h minus 4. This will be mod of minus h, which will be plus h. This will be mod of minus 1 minus h, which is nothing but h plus 1 plus h, which is 2h plus 1. So according to me, 2h plus 1. But that answer is, there's a negative sign before. So 1 minus 2h minus 1 by h. 1 and minus 1 get cancelled. Answer is minus 2. For the right hand limit, it's 3 plus h. So when it's 3 plus h, wherever x is, right, 3 plus h minus 3 plus mod of 3 plus h minus 4. 3 and 3 get cancelled, h. It's mod of minus 1 plus h. And as you know, it's h plus. This will become negative. So it will become 1 minus h. H and h gets cancelled. So the answer is just 1. So if I say the answer is just 1 for this, let's see what is the answer for f of 3. What is the answer for f of 3? F of 3 we would have found here itself. The answer was 1. See, can you see? We would have found f of 3 to be 1 by h, which is 0 by h. And therefore they are not equal. So LHS, left hand derivative, is not equal to right hand derivative, which shows that it is, therefore it is not differentiable. It is not differentiable at x is equal to 3. So similarly for x is equal to 4 also you'll do the same thing. See, supposing you want to prove for 4, so you're going to take a number line 4, you're going to approach from the right and the left. For the right limit is f of 4 plus h minus f of 4 by h. For the left limit is f of 4 minus f of 4 minus h by h. Okay, so then you have to go back to the question. The question is mod of x minus 3, mod of x minus 3 plus mod of x minus 4. It's what is f of x. See, whatever, supposing you want to find f of 4. What is f of 4? F of 4 is mod of 4 minus 3 plus mod of 4 minus 4, which answer itself is 1. So then therefore write here 1 minus f of 4 minus h. Mod of 4 minus h minus 3 plus mod of 4 minus h minus 4. 4 and 4 get cancelled. This will become mod of 1 minus h plus mod of minus h. I'm going to make it positive, so it will be 1 minus h. This will become just h. This will become, say, h minus 1. So you're getting a 2h minus 1. So you have a 2h minus 1 by h. So 1 minus 2h plus 1. What? By h. 1 and minus 1 should get cancelled. So let us see what I've done. F of 4 minus h. So I'm substituting for f of 4 minus h. This is mod of 4 minus h minus 3 plus mod of 4 minus h minus 4. Yeah? So which is mod of 1 minus h plus mod of minus h. So in this case, I know it's mod means I can write it as 1 minus h as 1 minus h also, and this can be written even as h. H and x is cancelled, you can also get an answer which is just 1. So in this case it's 1 minus 1 by h, which is 0 by h. Let's look at the right hand side. 4 plus h. It's 4 plus h. So it's mod of 4 plus h minus 3 plus mod of 4 plus h minus 4. 4 and 4 get cancelled. This will be 1 plus h plus mod of h, which is 1 plus 2h. Okay, so this is 1 plus 2h minus f of 4. What is f of 4? You already found that here it's 1. Can you see? So you put 1. 1 and minus 1 get cancelled. 2h by h. The answer is just 2. So left hand limit is not equal to right hand limit. This shows that it is not continuous. It is not differentiable. But the same question comes for continuity. Same question is asked for continuity. Then you have to redefine the function. You have to redefine. The redefining is very, very important. So let's take the same question, which is mod of x minus 3. Mod of x minus 3 plus mod of x minus 4 is equal to f of x. Let's see how to redefine this function. For continuity, compulsorily you have to redefine. What are the cutting edges? 3 and 4. So put in the number line 3 and 4. So the less than this mod function is less than 3 will become negative. Correct? Greater than 3, this will become positive. So when it's x is less than 3, you have to use the formula minus x plus 3. When x is greater than 3, you have to use the formula x minus 3. For this also again, when x is less than 4, you have to use the formula minus x plus 4. When x is greater than 4, you have to use the formula x minus 4. So now I'm looking at something. This for x is less than 4, this for x is greater than 4, this for x is greater than 3, this for x is less than 3, correct? So now x is less than 3. So x is less than 3 means it is less than 4 as well as less than 3, right? Obviously. So when it's less than 4 and less than 3, you have to use this condition and this condition. Both of them will be negative. So minus x plus 3 minus x plus 4, which is minus 2x plus 7. So thus on redefining, I'll get this as the formula. Correct? So because less than 3 means less than 3 and less than 4 also is applicable. Greater than 3. Greater than 3 means greater than 3 and less than 4. Greater than 3, what is the formula? This one, x minus 3. Less than 4, what is the formula? Minus x plus 4. X and x get cancelled. So answer itself is 1. Therefore, you understand that it's greater than 3's formula means less than 4's formula. Both of them have to be added. So let's go to greater than 4. A greater than 4 means greater than 3 and greater than 4. A greater than 3's formula is here and a greater than 4's formula is here. So x minus 3 plus x minus 4 is 2x minus 7. So thus you redefine the function like this. So thus you know when x is less than 3, the formula f of x becomes, f of x becomes a 2x plus 7 when x is less than 3. The f of x becomes 1 when x is lying between 3 and 4. When x is greater than 4, it becomes 2x minus 7. And you have to see, so you understand x is lying between 3 and 4. Where to include the inclusive symbol? Okay, somewhere I have to put inclusive also. Supposing, let's say if you're going to include this 4, you're not supposed to include here. Okay, supposing you're going to include it here, you're not supposed to include it here. Let's see, what is it when equal to 3? It will become 3 to 6 plus 7. 6 plus 7, 13. Okay, so somewhere you have to include and somewhere, so you put f of 3, it's mod of 3 minus 3 plus mod of 3 minus 4 is 1. So it includes at 3, so then don't include here, just include here. What about 4? What about 4? If I put 4 in the same formula, mod of 4 minus 3 plus mod of 4 minus 4 is also 1. So here alone include, don't include other places. I hope you're clear. Thus the function has been redefined. Now you have to check for continuity. Continuity means at 3. You have to come from the right and come from the left. So what is it? From the left hand limit x is equal to 3 minus h. For the right hand limit x is equal to 3 plus h. Limit of f of x extends to 3 from the left. Limit of f of x extends to 3 from the right. 3 from the left means less than 3's formula, which is 2x plus 7. 3 from the right means answer itself is 1. So idhula direct substitution, because there is no denominator, it's 6 plus 7. 13 is the answer. For the right side, you see 1 is the answer. So then they are not equal. Okay, how is it? You know that mod function has to be continuous function. Why is it not coming correctly for me? So if you're going to check from the 3 from the left and 3 from the right, from the left it's 2x plus 7. From the right the answer is just 1. And when I substitute x is equal to 3, I'm getting 13 and it's not equal. So I'm not getting it to be even continuous, which is dangerous, which is not the right thing. So what is the mistake? Let's see. Let's see from the beginning, okay? Let's see from the beginning. So then therefore you know that when x is less than 3, this is negative and that is also negative. So minus x plus 3, minus x plus 4. So minus 2x plus 7. So it's minus 2x plus 7. Shit, I made that mistake. It has to be minus 2x plus 7. So when it's minus 2x plus 7, when you directly substitute, it becomes minus 6 plus 7. It becomes 1. Everything is sorted. Left hand limit is equal to right hand limit. Sorry guys, I made a calculation mistake here. The redefining was wrong. So I hope you all understood. It's very, very important. This is to prove continuity. It will obviously, mod functions are continuous functions. Okay, like redefining is very important in a mod function when it is continuous. Continuity. For differentiability, you don't have to. I hope you understood the difference. Like this, you may have to do it even for approaching from 4. You can try it yourself. It's a very good sum. Every sum, the same formula you have to apply and do it. Okay.